Well, hello everyone. This is going to be a very short YouTube. I think it's only 4 slides because this is a short week. This is Thanksgiving week. So just a little bit of practice. You will have one problem already mostly done for you. If you hop on this, you can get done before Thanksgiving, but I'll give you a week anyway. Programming is one of these things that when you leave it go for a week, you forget it. So just a really short YouTube and one assignment that you can get done before Thanksgiving because it's not too bad. Okay, so we're just going to do the example in section 7.3 in your textbook. And this is an example using structures and functions together. And we already talked about structures, functions with structures in them as the argument. So this is an example using it. Kind of a cool example. It's an example using a fingerprint analysis. So a little bit of background material. Obviously this is a fingerprint, but there's 3 basic structures in a fingerprint. This is called a loop. This one's called a whorl, and then there's arch patterns. And it turns out that 65% of all fingerprints are loops. So now you're all looking at your fingers right now, right? And so when you have a person's set of 10 fingers in their fingerprints, you have to match which pattern occurs on their fingers and on which finger it is on to a database so you can identify this person. And so it's a very large database and very large number of possibilities, 3 patterns on 10 fingers. So compute that combinations and permutations that you can have there, and you'll see that there are a lot of possibilities. So the example in this section of the textbook is a simplified technique, and it's roughly based on what's called the Henry technique. And Henry was somebody who developed one of the early methods for doing fingerprint recognition. So here's basically the algorithm. You're going to assign a number to each finger. Actually, the fingers are going to be numbered 0 to 9, which is 10 fingers, and you will assign something to it based on which finger it is and whether or not you have a whorl on the finger. So this is our simplified first example of an algorithm for it. So fingertips are identified as R for right and L for left, kind of obvious. In addition, we will assign, instead of numbers for the which finger it is, it's T for thumb, I for index, M for middle finger, R for ring finger, and P for pinky finger. And so then you'll assign a value. For example, if you have RT or RI, which means a right hand thumb or right hand index, and it's a whorl, then you're going to give that a value of 15 and 16. And we're going to show you how you use these values. These values come up with a number that means what category you're looking at, so it reduces the database search for what the person, trying to find a match in the fingerprint database. So similarly, if RM or RR, so right hand middle, right hand ring is a whorl, then you get an 8, etc. What? That seems like a weird pattern, so I wrote the little what on the right hand side there because it sure seems like a weird pattern, but it must be based on some kind of a statistical analysis done on how many times whorls, arches, and loops occur on people's fingers. So, but that's the Henry technique. And then the next step you're going to do after you've gone through each one of the fingers is you're going to do this calculation called an overall category. And so these are the assigned numbers. Whether there's an RIR or whatever is assigned there, you're going to make this calculation, and that's going to say what category the particular set of 10 fingers falls under. So there are a lot of different categories it can fall under, and then once you've identified that this person's set of prints falls in a certain category, then you only search that particular category for a match. So that's how the algorithm works. So the example in the textbook, I have it done up here in Notepad++. You create a structure for a fingerprint. Fingerprint has an ID number, so that's like a person's ID number, or maybe his jail number, who knows. And then there'll be an overall category, and then a character associated with each fingertip, and there's 10 fingertips. And you'll get the main part of the program here. So for example, fingertip 0, this is a particular example, an ID number, just an arbitrary ID number. Maybe this is a person's criminal number, who knows, but he has 10 fingerprints, and the first one's a whorl, the second one's a loop, a whorl, an arch, a loop, a whorl, etc. An arch and a loop. And so that's this person's fingerprint pattern, and now you have to calculate what category that pattern falls under with the little formula. And then print the result, the category number result. So this is the rest of the program, just write out in your textbook. So you can also look at your textbook and get this number. And then there's a right here. Here is a function that you pass a structure to, the structure called fingerprint. So you pass this structure to the function that computes the category. So, and then here's all your initially declared, all of the different fingers are initially declared as 0, but when you pass the structure into the function, these values will become changed by this set of if statements. So that's basically the program. You type it up, you see it work. It works, but there was a mistake in the author's program. It's probably a typo that the publisher did, and there was a mistake, and so I typed it up just like I saw it, and then I compiled it, and the compiler told me what line the mistake was on, and so then I had to fix it. But it was a mistake a little bit that tests your understanding of what's happening in the program. So your homework assignment is going to be to repeat this program for yourself, step through it and see how it works, and then to do the modify the program step 4, modify step 4, that is at the end of the program on page 346. It says modify the program so that it prints the number of arches, prints the number in loops, and prints the number of whorls for the fingertips. So that's what you're going to do. You're going to modify it, so it'll make you understand the program as well. So I said this would be a very short video this week because it's a short week and you don't want to do homework over Thanksgiving, I am sure. So happy Thanksgiving, be safe, eat lots, have fun with your family. You should be able to get this short program done before you go away for Thanksgiving and forget about programming then, which is what most people probably do, but not all. Anyway, happy Thanksgiving, guys. You've been a good class and I've enjoyed you working on it. When you come back from Thanksgiving, I think we're going to do one little more thing about structures, and then we're going to take a preview look at C++, which is object-oriented programming, and you'll see some little differences and understand what object-oriented programming is. Making structures is sort of the beginning of that concept. So anyway, happy Thanksgiving. Bye.